Hey guys, and welcome to another video. In these next series of videos that I'm going to do, I'm going to pick out extremely hard exam questions that have come out over the past few years, and I'm going to show you the exact problem-solving methods that you can do. So, in terms of the video I had previously, where I told you how you can get a grade, insert whatever, like 5, 6, 7, 8, 9, I mentioned that in order to get the grades 7, 8, and 9, you really need to get good at problem solving. It's not just about being able to do the maths, it's about applying the maths in order to get to an answer. And so that's the idea behind this set of videos. If you want, there is a video where I go through all of ratios from grade 3 to grade 9, which I'll link in the description. That's going to be more of teaching you how to actually do ratios. This is going to be teaching you the problem-solving elements. So anyways, this question is super famous. I wouldn't be surprised if it comes up in your mocks or your end-of-year exams. But we have 4 types of cards in a game. Each card is either a black circle, black triangle, or white triangle. And as you can tell, there are 2 different colors. We have white and we have black. And then we also have 2 types of shape. We have circles and we have triangles. So, and this works similar to like a normal deck of cards, except much more simple because there's fewer suits and things like that. But we can say the number of black shapes to white shapes is 3 to 5. So this means that for every 3 black shapes, there should be 5 white shapes. Now don't forget, those shapes can either be circles or triangles as well. So these 3 black shapes, they could be 2 circles and 1 triangle, they could be 1 circle and it could be anything, right? And the number of cards with a circle to the number of cards with a triangle is 2 to 7. Now I am a big fan of kind of drawing things out, but in this case you might realize that you can't actually draw this out for a very special reason. For example, if I say 3 black shapes, I'm just going to color in the black shapes. Again, I don't know what kind of shapes they will be other than the color. And then we have 5 whites. Let's just draw 5, 2, 3, 4, 5. The problem is I can't actually make them with the correct number of shapes, because if you look here, it says the number of cards with a circle is 2 for every 7 triangles. But the thing is, that adds up to a total of 9, and this adds up to a total of 8. So I can't actually visualize this just yet, because we're talking about a different total. So, in my opinion, the best thing to do is to make the totals the same. So we're going to look for the lowest common multiple between 8 and 9, which is 72. So times by 9 times by 8. So we've got the black to white. We've times the ratio by 9. So instead of 3, it's going to be 3 times 9, which is 27. And instead of 5, it's going to be 5 times 9, which is 45. And then for circles to triangles, we have 2 times 9 for circles, which is 18. And we have 7 times 8 for the triangles, which gives me 56. Now they have the same total. And I can now draw this out if I wanted to. Obviously, the problem here is drawing out 72 shapes is a bit boring. But if you look, both these add up to 72. They have the same total. I actually don't really care about drawing them out in this case, because if you look, it says, express the total number of cards with a black shape as a fraction of the triangles. So in other words, I want the number of black shapes over the number of triangles. Well, how many black shapes do I have? Well, I have 27 black ones. And I have 56 triangles. That's your answer. Now, I know what some of you are probably thinking. How do I know that there's 72 cards in the bag? Because technically, I could have also made this 144. That's a common multiple. If you make this 144, and I want you to check this just in case, you'd have to make all of these twice as big. If I make the top and bottom of this fraction twice as big, it will still simplify down to 27 over 56. So it doesn't actually matter that this isn't the total number of cards. This might not be the total number of cards. This is the minimum number of cards. But because we're talking about a fraction, we're talking about a proportion, it doesn't matter if I double it. For example, let's say half of my sweets are red. Okay? Half of them are red. I could have 1 red sweet and 2 blue sweets. But I could also have 2 red sweets and 4 blue sweets and still get the same fraction when I simplify. Because don't forget, fractions are all about proportion. So in this case, I don't really care about the total number of cards, even though it says that. I'm actually working out a proportion. And that's a slightly tricky thing with this question. It was answered really, really badly, which is why I've called it a grade 9 question. Because remember, those grade 9 questions are just the final 10% of the marks, which a lot of it comes from problem solving rather than actual topics. But it's only a 3-mark question. And if you look at what I've done it very quickly. I've times them by 9 and 8 and then just made a fraction. But again, it's the problem solving. So whenever you do anything with maths, you need to think about what it's trying to tell you and what the point is. What does this 3 to 5 mean? What does this 2 to 7 mean? What is it? And what does this question actually mean in terms of proportion? Is it a number? Is it a percentage? What is it? I hope that helps. I'm going to do a few more videos like this where they're very short, they're very contained, and I'll link you to videos which explain in more detail what the topic is, but it's all about the problem solving. So without further ado, I'll see you in the next one.